you are more than welcome to leave if you know this like the back of your hand. But this, usually, students have a little tough time with this. Okay, so let's see, we have two forms, right? We have exponential form. And then we have radical form. So exponential form is when I have a base. I'll just say base. I'm going to try to use different colors for this. I have a base B, get it? B, base, to the, for the exponential form, I have the exponent divided by the root. Okay, radical form. Well, I'm going to have that radical because that's obviously what that means. So there's my radical for radical form. Now, my base goes underneath the radical. My exponent, now this is what is kind of sucky. In recent years, they've been changing more and more problems to have the exponent outside parentheses. Okay. It's been just a trend that's been happening. I don't know why. Never used to be that way. And then the root goes here. Okay. Now, we used to write this as radical. My base was underneath the radical. My exponent was underneath the radical. And my root would be in here. So just to confuse you now, because you guys are youngins, they're going to throw both forms at you. Isn't that nice of them to do that? I think this worksheet most of the time will have the parentheses here. Okay. Now, what happens here is our human brains are more adaptable to radical form. In other words, they like to solve, our brains like to solve it in radical form. Whereas it's easier to put in your calculators in exponential form. So you really have to know how to go back and forth between these two. You can always put an exponent in radical form and radical form into exponential form, just to make it more complicated. Okay, so the first exercise that you got here is just that. You're changing from radical form to exponential form, and then you're going to change radical to exponential, and then exponential to radical. Okay, so that's what you're doing 1 through 8. Oh, here's another thing to screw with your heads even more. Okay, exponents and roots. They don't call them exponents and roots and bases anymore. Okay, the base, well, this is cool, just to mess with your minds. The base is now called radians. The the root is now called index. And I think the exponent's still the exponent. I don't think they messed with me yet on the exponents. So what happens is, because these are kind of new terms, and new, I mean like, probably 100 years ago, I wouldn't say that. I was taught base, exponent, root. You guys, I don't know if they did this in Algebra 1 or not. I don't know if they taught you index, radicand, and exponent. So it sucks now because they mix up the terms. Sometimes in some problems, or even me, because I was taught old school, these terms get mixed up for me. I don't consistently use one or the other now because I kind of should be teaching index, radicand, and exponent. Just kind of, that's the new terminology of the new math. All right, so number one, it says I have it in radical form to put it in exponential form. So the base, I'm probably still going to use base, root, and exponent. So my base is P, and my exponent, well, they're using this form. My exponent's out here, and in exponential form, it's the top of the fraction. So my exponent is 5 divided by the root. By the way, if there's no root there, if there's no index, see, I already started. If there's no root, it's 2. Okay. But here, my root is 4. So there's my answer in exponential form. So let's do number 3. Again, if there's no root there, it's 2. So my base is m. My exponent goes on top of the fraction is 5. And my root is 2. All right, let's go the other way. Now it's in this form, I got to go here. So I need a radical. My base is n. My root is 6. And then we have the new style parentheses. And then my exponent is the numerator 5. There's my answer. Seven, my base. Oh, I need a radical. I might put that in there. So this is a radical, and this is a radicand. Nice, huh? Base is 4. I don't know what was wrong with base. My root is the denominator. Cube root 3. Parentheses. My exponent's numerator, which is 4. Let's do a couple simplification. And this is where I think I forgot to attach the little perfect squares chart, which I will. And if you watch the video, you'll see me using the chart. And I'll attach it, the flow chart for factoring. I think I forgot to. So I will give you the perfect cubes, perfect fourths, fifths, the chart that you see in the video. 81. And again, if you want to use, if they tell you you can use a calculator, obviously use a calculator. Okay. If not, you're going to have to do it with your brains. Remember, radical form is better for our brains. So I'm going to switch this to radical form. Base 81 Root is 2. I don't need to really put a 2 there. You could put a 2 there if you want. And then my exponent is the numerator 3. So let's simplify this. This we can pretty much do. Square root of 81 is 9 cubed. Okay. So this means it's 9 times 9 times 9. Yikes. I might have to use a calculator. I haven't had my coffee. Okay, so 9 cubed. 729. Now, it says not to use a calculator. It didn't. So I could actually put 81 raised, and again, put fractions in parentheses, raised to the 3/2, 729. See, could have done it that way. Yeah, let's go ahead and do it 11. Okay, remember, I have, if there's not an exponent there, it's a 1, right? So I have a power raised to a power, so I have to apply a property first. Okay, so I have 27 raised to the 1/3, or in other words, the cube root of 27. And then I have 9 times 1/3. Well, 9 times 1/3, if I cancel out a 3 and 9, I get a 3. In other words, 9 divided by 3 is 3. 3 divided by 3 is 1. This all equals 3. So I have n cubed. Now, all numbers we should simplify. The cube root of 27, or if you want to put 27 raised to the 1/3, should get 3. Yep. Yeah. And on the videos, I went ahead and did a couple of these. You guys are lucky this year because of this stupid COVID. You get the easier problems where they all work out. So this is the square root where you're taking the square root of each one of these. There's a 2 there, right? Square root of 16, 4. Those are going to be all perfect squares. These are going to be all perfect cubes. M to the 2, and you're going to divide by 2, is 2 over 2, or m to the first. And 2 over 2, again, is n to the first. Why does it do this one too? Cube root 27, remember, it raised to the 1/3 was 3. 3 divided by 3 is 1, so it's just x to the first. 6 divided by 3 is 2, so y squared. And there you go. Any questions, guys? All right, I'll post this video on the 6.4 part 2 lesson along with this note sheet. Okay, that's what I've been doing. Questions, comments, concerns?